there's an important point before this talk that there are actually two people at this conference with the name spelled the same way. There's the other one right there having coffee. This is Brian Duggan, and I'm Brian Duggan. So I believe we have allomorphic names. Okay, so this talk is about command line argument parsing, extending Perl 6 command line argument parsing using metaprogramming. So despite the title, this is actually based on my experience using Perl 6 in production. So I'm going to go through not the production code, but a lot of the building blocks that I used building out a command line application in production. I work at a company called PromptWorks. I'd like to thank them for sending me here. We're based in Philadelphia, and we are a software consultancy. Okay, so I'm going to divide this talk into two parts. The first one will be about the built-in command line parsing functionality, command line argument parsing functionality in Perl 6. And then the second part is going to be extending that using metaprogramming, by which I mean dealing with functions and subroutines and signatures as first-class objects and getting some information about them. Okay, so let's talk about command line argument parsing. There have probably been many talks about command line argument parsing, and you have all probably done it at some point. How many people have written things that use command line arguments? How many people have liked using getopt or the equivalent? Okay, some people like it. For me, I've often struggled with using getopt. I've always found that it seems like it's harder than it should be. This has been sort of, I did a little Google search, and this is kind of what it looks like from afar when I think of command line argument parsing. You've got this huge specification of stuff, and you have to sort of figure out, what they type and how you're going to parse it and how you're going to map it to what you're doing. And I've always felt, it shouldn't be so hard. And I guess one of the reasons that I felt that way, so here's an example. Anybody recognize what this is? Graphics magic, right? So here's an example, image magic, I guess, now graphics magic. So this is an example of doing a transformation of an image. And you can see there are a bunch of command line options. We're doing a resize, and this is actually one of the examples from the man page. And it's a little bit terse, and you can imagine parsing it would be kind of tricky, but you would set up some sort of specification. But at the end of the day, when you're running something from the command line, it's kind of like you're calling a function, right? And the thing on the bottom, to me, makes a lot more sense, because you can see, like, okay, these are the arguments I'm sending to the function, and these are the values. So it would be nice if there's a way to get straight from the command line to a function call. The only thing that makes it different is that your function calls have to have a lot of semantics, like you need positional or named parameters because on the command line, sometimes you have things that are positional, sometimes you have options, which are, start with a dash. You may need some optional or some required parameters. You may also need support for types. For instance, some of the options that come in are Booleans, some are not. Short and long names, documentation. So these kinds of things are in argument parsing libraries, and that's why we use them, so that we can turn stuff on the command line into function call. But the good thing is that in Perl 6, the subroutines support all of the things that were on the previous slide. Along with that, Perl 6 also takes subroutine arguments and turns them into function calls to a special function that's called main, in all caps. So I'm going to go through a few examples of how it does this. And the examples I'm going to look at are the ones that I just described. So some examples of how positional versus named parameters get handled, required parameters, examples of types, defaults, and then aliases, constraints. We'll see how multiple dispatch comes to play, and how the documentation is even can be taken from the subroutines and put into command line documentation. Okay, so first of all, how many people have written a program in Perl 6 at all? Okay, how many how many people have used Perl 6 in production? Okay, how many people have used the command line argument stuff in Perl 6 for parsing it? Okay, so for a lot of people here, this will be review because you've used some of these features. And then hopefully the second part will be somewhat new. Okay, so first of all, with no argument parsing, you can always use this dynamic array @*args, which has the stuff that came in split on white space, and you can parse it however you want to. But as soon as you make a subroutine called main, then instantly you get argument parsing. So now if we have a program called greet and we run it, and then we add an argument like --help, which does not match the arguments that go into main, we get a usage message. So in fact, you get this usage message no matter what arguments you give it if they don't match what's in main. There's actually something a little bit different about help and the other one. Does anybody know what it is? So what's that? Well, they both generate a usage message, yes. They actually both go to usage. There's one difference. I don't know about exit code, but it could be. But I do know that when you use --help, it sends it to standard out instead of standard error. So I just learned that this morning. But otherwise, there's nothing special about help. As long as it can't match what's coming into main, it'll give you the usage. Okay, so positional versus named parameters. So the one on the top is positional, and then to have a named parameter in Perl 6, you put a colon in front of it, and this automatically turns an argument with dashes into a named argument to main. Okay. So these two command line invocations are similar to calling main, one with a positional argument and one with a named argument. You can indicate required parameters also. There are two ways of doing that. One is by saying is required, the other is by adding an exclamation point. And you can see that it sort of fixes up the usage message using the standard convention, like there are no brackets around the argument indicating that it's mandatory. You can also, one of the cool things, one of the big things in Perl 6 is that it's gradually typed. So if you want to give types to the arguments of your function, you can specify them. So if we give our arguments a string and a Boolean type, then you can sort of see that the usage message that gets generated automatically says, oh, this one takes a string, and the other one that's a Boolean is a flag that's either on or off. There's a way to specifically, so if you omit it, then it's false. If you put it there, it's true. You can explicitly say it's false too by putting a slash after the dashes. But the types make their way into the main subroutine. Similarly, if you have defaults, you can put those in your declaration of main. It's pretty straightforward. You use an equal sign, and now instead of having to require a parameter, you can, if you run this with no parameters, then it'll default to the value. One thing you might notice is that the default usage that's generated doesn't have your default value. So in part 2, I'm going to talk a little bit about how you can change that. Also convenient is short names and long names. So what's kind of cool here is that when you use this syntax for, you use a colon and a short name and you put parentheses around your argument. So this is not just something that works for the command line. You're familiar with it from command line parsing, but it works at the function level. So now if somebody calls your function, they can send different aliases for the same incoming parameter. So it's also sort of a nice way of providing, compatibility if you're making a library and you want to have various options, various names for the same option. Constraints are also possible. The where clause adds a constraint. Here's an example of ensuring that a particular argument matches a regular expression. So we're saying, greet only somebody whose name has a lowercase. If we do a case-insensitive match for Bob or Robert. So if we do Roberto, that includes the string Robert. So that passes the type constraint, or not the type constraint, the check constraint. And if we don't, if we say greet Joe, we get our usage message. A nice thing about constraints is that if you have several different functions with non-overlapping constraints, then you can instead use a multi-method, or a multi-sub in this case. Perl 6 provides multiple dispatch. So here if we have one main which takes Bob as the first argument, and one that takes Alice, then the usage actually figures out that there's two different ways to call this program, one with Bob and one with Alice. And when you send Bob, you get the first one. When you send Alice, you get the second one. And then finally, we have documentation. So not only is there a pod like in Perl 5, but even comments that begin with a number sign can be used as what's known as declarator pod. So these, by putting a vertical bar after your pound sign, that says attach this comment to whatever is coming next. And when you have an equal sign next to your number sign, that means attach this documentation to whatever came before it. So in this example, we've got this multi-main, and the first thing we do is we say, this comment is say hello to somebody, and it's attached to this main. And then the argument here, which is a required parameter name, also has a comment attached to it. And the comment is the person to be greeted. So then the usage intelligently sort of looks through this and says, oh, okay, well, this comment is attached to this main, so I'm going to print that out as the documentation. And then also, I see you have this comment attached to this argument, so I'm going to print that out as a documentation for the argument. So you get a lot of stuff built in already for your metaprogramming.
Never enough.
It's never enough, which brings us to part 2. But one extra little thing here on the bottom I did notice while using this in production is that by default, you have to put all of the named arguments at the end and the positional ones at the beginning, but there's a little flag in Rakudo you can set to change that, so you can sort of intermix your positional arguments and your named arguments on the command line. And that's called main allow named anywhere, and you set that to true in your program. Okay, so moving on, metaprogramming. So what if it's not enough and you want to do some extra stuff? All right, what else could we possibly want? We have so much already with our command line argument parsing. So, well, let's look at something like Git. It's got subcommands, it's got help for the individual subcommands, it's got all kinds of crazy stuff. So I'm going to go through a few examples of extending the built-in stuff to support subcommands, options for your subcommands, displaying the defaults, which is one of the things that I said doesn't happen with the built-in stuff. Displaying the constraints, and then finally, as the code base gets bigger, you may want to break it out and not have all your mains in one place, and maybe even add some testing. Okay, so the way we're going to do this is with the Perl 6 meta model. Okay, so we're going to be exploring essentially the way that the built-in the built-in dispatcher and the built-in usage function works by introspecting the different types, the subs, the signatures, the parameters, the constraints, the types, and the introspection methods, which are like, always remind me of like a who's on first routine. We have why, what, who, and how, and these are all methods that are available to call on any object, and they will tell you something about the object. So for instance, we'll start with showing the defaults. So here's our sub main, and then we're going to generate our own usage just by declaring a function called usage. And if we look at ampersand main, we can call a method called signature on it. Signature returns a signature object. The signature object has a method called params, and each of the params has a method called default and a method called name, which tell you something about the parameters that are declared for main. Okay, so in this case, so I'm just going to go through that one more time. Okay, so ampersand main is an object of type sub, and then you could look at the documentation for this in docs.perl6.org/type/sub, and you'll see all of the different methods you can call on sub. One of the methods is signature, which gives you an object of type signature. And that has a method called params, which returns a list of things of type parameter. And parameter has a method called default, which returns something called a block, because the defaults can actually be generated at runtime. And then you can call the block and see the default. So that's how in the previous slide we were able to we have $default with two parentheses, which means call this block, and we get the name, $name, and we get Bob as the default. So these are some of the building blocks for how you can make your own usage that's more sophisticated than the built-in one. Okay, so what about constraints? It's very much the same thing, which is that a parameter has another method called constraints. And for constraints, the constraint can sort of be anything, right? So in this case, our constraint, by calling caret name, we are finding out that this is a regular expression. If you're wondering what that caret name is, I'll tell you in a second. And then $C is actually printing out the regular expression. Okay, so caret name that I'm calling on $C to figure out what it is shorthand for $C.how. Remember I was talking about the different introspection methods. And how gives you the higher order workings of something. And then, so you say $C.how.name. So there's a shorthand for that, which is .caret name. There's similarly a what, which would return a type object, and then calling the gist gives you the stringification or a human readable version of the regular expression. Okay, so what about the type? So the same thing. We have a parameter. The parameter has a method called type, so we can use that to print out the type of things. It's a little trickier if there's a constant, like we had in our examples, where you have sub main and then there's just a string called Bob, because in this case, what's generated is a junction, which is probably a talk in itself. But the good thing is to figure out what the value of the junction is. You could always just stringify it using Perl and then parse that, which is kind of what I'm doing here. Which is what I'm doing here. You can sort of use this trick for your subcommands. So if you have a multi-dispatch main and you've got a bunch of different constants that are your subcommands, basically you can call ampersand main.candidates. So the sub also has a method called candidates, which tells you all the different candidates that a multi might use. Each of those is also a sub, and you can find what the first argument is, the first constraint is for those subs. And then you can also call .y in order to figure out what the documentation is and print that out yourself too. Okay, so here we see another implementation of the original usage, but with the additional advantage that we can show our defaults, we can show our constraints, and also we can have different arguments for different subcommands. Okay, so a couple more things. So after your project grows, you may have a lot of mains, and you may think, oh, I don't want to have all these mains in one file. It's hard to maintain. So can I just have some sort of a directory structure that looks like this, where I have alice.pm and bob.pm, and then maybe I have my main program next to it. And actually, the first step to doing that, you just take your mains, put them in those .pm files, and label them as isExport, and you've broken up your file, and everything continues to work fine. I guess dot is still in ink with Perl 6. So you can just use those and everything works fine. But that may get a little bit cumbersome, and then you may decide, well, actually, especially if I want to do testing, maybe I'll just call them something else instead of calling them main, and then export those into my main program, and then just let the dispatcher do its work from within my program instead of dispatching to all the different mains. And so then you can sort of change the signature of main to slurp in all of your positional arguments and all of your command line arguments, and then pass those along, and it'll call the right command. So you can sort of continue to use the same design pattern even if you're not using main. And this is handy if you want to test your command line program, because you can sort of pull each of these in, and then you can take your ampersand command, you can introspect it, you make sure the documentation is right, and you can simulate runs and have some nice testing for your command line application. So in summary, there's a lot of built-in good stuff with Perl 6 command line parsing. And not only is it good for putting something together, but if you find that your project starts growing, you can also continue to sort of build on it and refactor it, and the same design patterns continue to work, and you can use it as a starting point for a bigger command line application. Thank you. I think it's lunchtime right now. I don't know if I have time for a question.